Welcome to Steel Stories by US Steel. In this podcast, we explore the wealth of knowledge from leading industry experts to help you navigate the infinitely developing, renewable world of steel.
Well, welcome back to Steel Stories and part 2 of our deep dive into the future of sustainable steel. If you missed part 1, we covered the basics: how steel is made, why it's such a big contributor to CO2 emissions, and how the industry is already making major strides to cut its carbon footprint. But today, we're looking ahead. What if steel could be produced with zero emissions? In this episode, Jeff Becker, a sustainability engineer at US Steel, walks us through the innovations that could transform the industry, including hydrogen-based steelmaking, large-scale carbon capture, and making steel with what's called direct reduced iron. We'll also discuss the global push for cleaner steel, what it takes to build a truly net zero steel mill, and how policy, infrastructure, and investment will play a crucial role in getting us there. The future of steel is changing fast, and this episode is packed with insights you won't want to miss. So let's jump in. What is the hydrogen replacing in effect?
It's replacing some of the coke, but you can't replace it all. So it's replacing some of the coke, replacing some what we would call auxiliary fuels.
So you really need less coal as a result of using hydrogen. And burning coal is a huge source of CO2.
Right. You still need some. So you can reduce it maybe 20%, 30%, but you still need some.
Okay.
So even if you use hydrogen in the blast furnace, that's a good step, but eventually you're going to need to put carbon capture on the blast furnace.
Okay.
And so what we're doing with that is we have a number of different projects within US Steel where we're looking at different aspects of carbon capture. One of them at our Gary Works is working with a firm called Carbon Free, where they are going to take some of our blast furnace gas and build a plant. And that's a starting point. It's 50,000 tons of CO2 a year. Then we can scale up further. But you can't go for 100% right at the beginning because it is still in development.
Right.
We're also doing a couple different projects at our Edward Townsend plant here at Mon Valley Works, where we are working with the National Energy Technology Laboratory, which is a part of the U.S. Department of Energy, or the DOE. And they did some lab work at their laboratory outside of Pittsburgh, where they've developed different membranes to try to separate CO2 from other gases in industrial off gases of different types. So we're going to be a test bed site where they're going to test the efficacy of these different materials they've come up with in the lab to see how do they work in an industrial site? How well do they capture the CO2? How often do they have to be cleaned or replaced? Things like that. And that's really more of a not quite fundamental research because it is still applied, but it's more early scale research, I would call it. So we can, again, figure out the best way to capture that CO2, because even if we use hydrogen in the blast furnace, we're still going to have some CO2.
There's an issue with CO2 capture. If you get really good at it and you're capturing a lot of CO2, you got to figure out how you dispose of it. So in many cases, those kinds of projects that are taking a lot of CO2 out of an industrial process are increasingly being located near CO2 pipelines or CO2 sequestration facilities, which is, that might be a future for some of the steel industry too, but we're not really doing that yet. Because relocate a steel plant. Yeah.
Right. And it's early development. And if you look at the reason why blast furnace steel mills are where they are is because of access to iron ore and coal. So it's not necessarily access to where you might sequester CO2. So then you're talking about additional pipelines, things like that, but those are all potential. But again, that kind of thing is infrastructure that's really beyond the steel industry, because it would be whomever we would say sell the CO2 or partner with someone to sequester it, having to build pipelines to take it from our plants to wherever is geologically suitable to sequester.
Right.
Or you put a chemicals plant on site to be able to use that CO2 as a precursor to something else, say replacing, drilling oil out of the ground, which would be the ideal.
Right. Okay. I have a question for you.
Yeah.
Nippon Steel, which is has been for some time talking to US Steel about acquiring it. They are very good in some of their plants in Japan on figuring out ways to decarbonize the integrated process. Am I right about that?
Yeah, so there, I mentioned the Japan Iron and Steel Federation project with the mini blast furnace.
Right.
That's actually located and run by Nippon Steel.
Right.
Although the other
Okay.
Japanese steel companies do get access to the data and everything, Nippon Steel is hosting that. So they've been doing this research for a long time.
And that means they are one of the companies of all in the entire global steel industry that understands best how to decarbonize the existing processes to the degree that it's possible.
Yeah, and on this mini blast furnace, besides the hydrogen injection side of it, they also have a carbon capture unit.
Right.
So not only are they studying the hydrogen side of it, they're studying the carbon capture unit.
Yeah.
They've built a couple small carbon capture facilities, a couple of their steel mills for some of their smaller off-gas streams. So that is certainly promising going forward. And then another way, we've talked about the EAFs with DRI and eventually hydrogen. We've talked about blast furnaces and CO2 and, CCUS. There is another sort of in-between hybrid option that people are looking at where you take a DRI plant and put it into an integrated facility. You would replace the blast furnace with a DRI plant.
Okay.
The problem is, as I said, the blast furnace, you get liquid to go into your BOF, which you have to have because that's where the energy comes from. DRI is a solid state process, so the material comes out solid. So they're looking at doing a DRI with lower quality pellets, less iron in them, and then adding a melter, an electric melter, to make an equivalent hot metal that comes out of the blast furnace, and then use that in the BOF. So that's sort of we'll call it a middle option between keeping your integrated with carbon capture, going, 100% EAF with whatever you have on the front end, is doing this sort of hybrid approach where you still keep your oxygen steelmaking plant, your BOF.
What does the BOF acronym stand
for? BOF is the basic oxygen furnace.
BOF, basic oxygen furnace.
And that's where we take the liquid iron from the blast furnace with a little bit of scrap and convert it to steel, from iron to steel. So you can keep that, but you need that liquid. You need to have 75, 80, 85% of your charge be liquid iron, because of the chemistry and the temperatures of the process.
Okay.
So you can't use DRI directly as 75% of the charge because it's solid. So you have to have something in the middle. Electric smelter, open bath furnace, there's a bunch of different terms, bunch of different technologies out there. But they, in essence, what they do is you end up taking that solid DRI product and you melt it in a separate, specially designed furnace just for melting.
Mm-hmm.
And then you take that liquid and you make a liquid iron that then is 2,500 degrees Fahrenheit that you send over to the steel shop. And so the advantage there, or what people are looking at there, is if you can't get super high grade iron ore pellets, if they're not available, if either you don't own them or you can't get them, then that causes too many problems trying to use an EAF. So it's an alternative way to use a lower quality iron ore pellet, still make DRI, so you're still using first natural gas and eventually hydrogen, so you avoid the coal use and coke use. Then you go through an electric process, then you go through the oxygen steelmaking. Okay. And so if you think about it, it's really taking the blast furnace, which does the smelting with chemical reduction and melting because you get a liquid, and split it in two.
Right.
You do the DRI where you smelt, and then you have the melting, an electric melter. Get a lot of electricity, so same thing with the EAF.
Melting and melting. I love that.
You need to have clean electricity, whether that's nuclear, whether that's hydro, wind, or solar, but then you use your existing BOF. So, but I think what's going to happen, what we're going to see globally is, depending on the regional and local conditions of scrap availability, electric availability and cost and type, and iron ore availability, cost, and type, we're going to see different configurations globally. There's no one configuration that's going to be 100% of the steel industry in 30 years. And so each company and even companies, each site within a company are going to have decisions on what they look like in the future. And we're going to see all these different combinations come up in the next 20 plus years.
So what would you say is your best guess about what percentage of total emissions the steel industry can eliminate, even as, of course, it continues to grow because the world economy is growing, and that means it's more steel? I mean, how successful is decarbonization likely to be in the steel industry in the next, say, 10 years, 15 years?
So I would say 10 to 15 years. I'd still call that medium term. I think you're going to see growth in the DRI process. We're seeing that with announcements globally where they're going to all pretty much start up with natural gas, but all be designed to move to hydrogen when green hydrogen is available at a reasonable cost.
For the direct reduction of the
for the direct reduction. Whether that is combined with an EAF or combined with a melter and BOF, we'll see both. There's announcements, there's projects under construction now for both. Carbon capture is a little bit further behind as far as announced projects. So I think we're on a good path. And, but I think, you look at the steel industry the industry makes 2 billion tons of steel a year.
Wow.
800 million, 900 million of that's in China. India is growing and they're installing new blast furnaces. So I think you're going to see in the developed world, we're seeing the pressure to reduce our emissions, and you're going to see that. And, a lot of companies have 2050 net zero targets, as does US Steel. Some are a little bit earlier. Some are pushing, 2060, 2070 targets, especially when you get into like China and India have national targets for not just the steel industry, but for their economies. And Europe, we're seeing an acceleration. So, I think that's sort of a long way to say we're on a path that's going to take a lot of money, a lot of when we're talking equipment, we're talking billions and billions of dollars in new DRI plants, new EAF, carbon capture. We don't necessarily have how much is it going to cost capital and operating. Estimates are that to decarbonize the steel industry, you're talking $4 to $6 trillion.
Really?
And that's not just within the steel industry. That's also includes the electricity side of it that we talked about before. It also includes the downstream of, pipelines for carbon capture and all that. But
which would have a lot of benefits for society besides just for steel.
Exactly.
So some of that 4 to 6 trillion is not just going to benefit the steel industry, it'll benefit society at large.
Correct. Yeah. And those are the estimates that the World Steel Association has been using. So, and I know it's a wide range, but we're talking a whole lot of money here. And so access to capital is going to be very important. You get away from the technical side, you go to the business side. These projects all need a business case. Customers' willingness to pay additional. Our customers want us to decarbonize. So it's not just we're not doing this just because to do it. We have customers that want us to do it. We have our investment community that wants us to do it. Governments around the world, different places around the world have different measures and requirements for greenhouse gas emissions. So, we're on this path, we're making progress, and could the progress be quicker? Always, but there is a limit, like I said, financial, and also we're going to have a lot of people build all this equipment globally. There aren't all that many companies that sell DRI plants, for instance. There's only a few. So there's going to be a technology and even a learning and a staffing potential on engineering talent, construction talent. Because these are fairly, these are specialized builds and specialized equipment and manufacturing of this equipment. It's not made everywhere. So there's a lot of work that has to be done for the steel industry and other industries, related industries, to do this. But I do think we are on a very good path.
Okay.
And our work and taking that from the global down to US Steel. Certainly our work, Big River 2, which started up, will help us meet our targets. The work we're doing with carbon capture, both on a project that's going to actually be doing capture as well as some of the more earlier stage research, is important. And then taking what we learn from what other industries are doing, or what's being done around the world, we take that and how we incorporate it is all going to be important. It's all going to be part of this journey forward.
Something like the new Big River plant with the solar field attached, you talk about a net zero target by 2050. Even when that's operating, it's still at the moment not net zero, because the iron itself will have to be acquired to some degree from processes that still emit CO2 and other emissions.
Yeah. And when we look at our net zero target currently is scope 1 and scope 2 emissions only. Scope 1 emissions are our direct emissions. Scope 2 emissions are the emissions from the purchased electricity. We have
Right.
not yet rolled in scope 3 emissions, which would the big part of it would be emissions from purchased goods,
Right.
including outside purchased iron ore units, pig iron, HBI. But yeah, so the first part is, the electricity we get. The solar helps, but it's not 100% solar. There's a lot of nuclear in that
Right.
part of the country, so we have that benefit
There's
of
some backup to the solar when the
Yeah,
sun's
and
not
it's
shining or the
right.
battery's not
right,
exhausted.
the grid is around 65% nuclear in that area already. So
Right.
that's a big benefit. And then so you've got that, getting to zero includes that, and then it includes, we sort of touched on it but glossed over, we do have our other downstream processes use electricity, use natural gas.
You mean the casting and the rolling?
Yeah, the casting, the rolling, the coating. So again, these things, we focus on the primary end of where we make the iron and steel, because that is the bulk of the emissions. But once we start reducing those, then our downstream operations, the percentage contribution increases. So we're looking at ways there. And part of it, again, the electricity, the same thing on electricity that helps the EAF will help the electric usage in the rolling mills and things like that. With natural gas usage, we can look at, again, replacing it with hydrogen. If that hydrogen's green, we can look at, instead of natural gas heating, can we do electric heating?
Right.
Which again goes back to electricity, but increases our electric consumption,
Right.
which goes to that part of the conversation about, electric generation and, how much generation is there going to be for society as a whole, as we're trying to both move away from coal and natural gas, as
Yeah.
well as increase then how much electricity we're consuming.
Yeah.
So it all ties together, and you can't separate the steel industry from society, because, we're talking about, we've really focused on the consumption side of the steel industry, but, there's also the product side that, our steel is what goes into windmills. The towers and everything are
Right.
made of steel. A lot of times solar frames, the underlying frame that's holding up the photovoltaic cell is made out of steel, and we make
Right.
it out of steel. The motors, you think about a wind turbine, it's got a decent sized motor up in the turbine. The steel that makes up the motor is electrical steel that we make at our Big River facility, with a line that started up a year and a half ago. And like I said, we've been focusing on steel as an emitter and having to reduce the emissions that side. But steel also has great contributions to make in the product. Electric vehicles, again, an electric motor has steel in it. The motor itself is made out of steel laminations and
Right.
electrical steel. The cars themselves, of course, are also made out of steel. And
Yeah,
you
there
think
you go.
about safety and trying to lightweight. When we think about traditional, internal combustion engines, you think about lightweighting, improving fuel economy, improves emissions. Well, in a battery electric vehicle, lightweighting improves the electrical efficiency, improves your mileage, improves your range. And you need to obviously have a strong, cage around the battery itself. And, so the CO2 pipelines are going to be made out of steel. The drilling, when you're sequestering, is going to be the same drilling equipment that's used today for drilling oil, again, made out of steel.
Yeah.
So steel isn't just, emitter, it's part of the solution to society's problems,
Right.
society's issues with climate decarbonization.
Yeah.
You look at, steel frame housing and some of the products there that we make out of steel. When you talk about climate change, you talk about increased wildfires, steel can help with that. Steel can help when you talk about barriers to water and flooding, break walls, things like that are made out of steel as well. So we need to look at steel as both. Yes, we have issues to work on. We have a path forward that's going to take time, but we are also part of the solution to this societal issue of climate change.
Right. Okay. So we're at a time when government policy may be shifting somewhat, but obviously the government's incentives and policies are going to be very important in the speed with which all this happens. What government policies do you think are most important for ensuring that this moves forward as fast as it possibly can?
Great question. And I think one is we talked a bit about the electricity, so improving generation and transmission. And the transmission of electricity, the siting of projects, permitting, transmission lines, things like that, absolutely vital. So any sort of government policy that assists with that would be helpful. But those kind of programs are great to show that, to help provide seed funding, because it's not covering the whole cost, but to provide seed funding for those kind of projects, and doing, some of the more fundamental research at the national labs, whether it's NETL or whether it's the DOE national labs that are doing research on hydrogen generation, hydrogen
Right.
storage and transmission, doing the research on carbon capture
Right.
technologies. And that's important to continue because, again, those aren't just the steel industry. It's really all of heavy manufacturing gets those benefits.
Yes.
And yes, sometimes it may take 10, 15 years for the benefit to reach industry, but that's where that research needs to be done in concert with universities. And we do the same thing. We work with a number of universities on different, research that's related to iron and steel, some of it related to decarbonization as well. But I think there's certainly a place, in the US for this kind of funding. And we see this funding globally. The European Union is giving billions of dollars to various steel companies to aid in their transitions.
Yeah.
Certainly keeping those policies here in the US, even with the administration change, would be important.
Yeah. We've covered so many great things. I think we're really in good shape. But one question I wanted to ask you, we might have room to include, is given that there's so much growth in the developing world right now, and this is a global need, steel has to go in every economy. If somebody's, in some developing country needs to build a greenfield steel infrastructure today, what is the greenest way that is the answer to this card? Because it depends on the price of electricity and all the other inputs that you were describing before, or is there generally a state-of-the-art solution that is most commonly applied to be as low emissions steelmaking as possible?
I hate to give the scientist answer of it depends, but it depends.
Okay.
It really depends on the availability, what raw materials are available,
Yeah.
what's the type of iron ore that's available, or is scrap available? That's the first question.
Yeah.
Then the second question is, what is the availability and price of energy, whether that be electric, whether that be natural gas. Electric obviously ties into hydrogen. And then what is the demand going to be? And is this mill going to be needing to make, 500,000 tons a year of rebar? Because that looks very different than the mill that's making 3 million tons of automotive sheet.
Right. Or electrical steel.
Yeah, or
Right.
electrical steel or things like that.
Yeah.
So I don't really think we can say there's one end all be all model that everyone can follow, even for a greenfield mill, so it depends.
Well, one of the things that really comes through loud and clear, Jeff, in the way you analyze this is, for all the progress the steel industry itself and U.S. Steel and companies, other companies, including Nippon, companies in Europe, et cetera, are making, it really is an all of society effort, in effect, because, you've got the electricity production and transmission infrastructure that has to keep moving forward. You've got carbon capture technologies that have to continue evolving. You have hydrogen production has to go further and faster toward green hydrogen. So it's not like the steel industry autonomously can just start doing things differently. It's really a ecosystem problem that you all are at the center of, and you're clearly making a lot of big changes as an industry going forward.
Exactly. And I think that's a good way to put it, is it is the whole ecosystem, and everyone needs to be involved. And the steel industry, we're doing our part, and we do need this assistance. And it's, and like I said before, our customers want this. Their end customers want this. It's a global economy. So, we supply, for instance, we supply every automaker here in the US that's located in the US, whether they're based here or not.
Yep.
And that includes for their vehicles that they may export to their home markets or export to Europe or wherever. Our investors are increasingly wanting this. They're seeing climate change as a risk, and they want to know how we're going to de-risk not just ourselves in our physical operations, but how are we going to de-risk our part of the supply chain upstream and downstream to our customers. So they're interested in this. And, so it's going to continue. And, we have these drivers and we're interested in doing this the right way. And it has to be economic. We are in a business. We need to make money to continue to operate. So we have to, spend our money wisely, but more and more of what we spend is going to be on projects that do reduce our emissions as well as, contribute to our bottom line.
Yeah. And one of the great things is there are more and more customers who really are pushing companies like US Steel to decarbonize to help them meet their own goals. So that's a good thing. Well, this has really been great. Well, Jeff, thank you so much for this second episode of a great conversation we had with you on how steel is made, where steel making is going in the future, and how this absolutely central industry is going to decarbonize itself going forward. Great conversation. Thanks again.
Thanks again for having me, David. I appreciate the time to talk to everyone.
Well, great. And so join us again for another episode of Steel Stories. We'll see you again soon.
Steel Stories is brought to you by US Steel. To find out more about our sustainable steel solutions and how our Best for All strategy allows us to re-envision the future alongside our customers, visit www.ussteel.com. Search for US Steel in Apple Podcasts, Spotify, Google Podcasts, or anywhere else podcasts are found. And make sure to hit subscribe so you never miss a future episode. On behalf of the team here at US Steel, thanks for listening.